Let's get started. And I'd like to start. Well, yesterday was a tough day with all those crazy word problems. That was like, and you're not going to believe it, but today you're going to have a couple of real doozies today.
Oh, no.
I know. But to help us get warmed up, I want to do one like we did yesterday. I'm going to just change the numbers a little bit. So let's say that this is an extra problem. So you might do it on a piece of paper. I don't know if you have room on this to do it, but somewhere. So we know the height of a cylinder is half of its diameter. So in other words, you have a really flat cylinder. And our job is to write the volume as a function of a radius. Okay? Now we did one just like this yesterday, I changed it a little bit. So let's review our thought process. First of all, I'm going to draw my cylinder. It doesn't have to be perfect, just so I have a visual.
Is this an extra?
This is an extra problem that I'm just doing to try to get us back together before we tackle some really wild things. Okay? So there's my cylinder. I know that the height is 1/2 the diameter. I also know that the volume of a cylinder is pi r squared h. This right here is the formula that is in every geometry book ever published. That is a great formula. But volume is in terms of radius and height. And my particular problem wants it as a function of radius only. Okay? So that means I have to get rid of this h. Well, it's 1/2 d, but I don't really want to put 1/2 d in there because then I would have r's and d's. Tell me about diameter. What do you know about diameter?
Double radius.
Radius squared.
Not radius squared.
Radius.
2r. So, if diameter is 2r,
What is the radius?
can I do that? So now h is this. Well, what does that simplify to?
R.
H is just r. So then I can come down here and say my volume is pi r squared times r. And that would be pi r cubed. Okay? Let's do one more. So let's do this one. Here's another. This is extra. Just an extra. So the base of an isosceles triangle is, let's say, 3 times the length of the side. And we are going to write the area as a function of the base. So first of all, what is the base, what is the main formula? What is the basic formula for the area of a triangle?
1/2 base times height.
1/2 base times height. So area equals 1/2 base times height. that formula is great. It's perfect, it's wonderful, it's accurate. But notice, area is in terms of base and height. And I only want it in terms of base. So I need to get rid of that H. Agreed? So let's draw a picture and see what we've got here. Here's my isosceles triangle. And the base is 3 times the length of the legs. Now, because I want to keep my B, I'm not going to change that. I'm going to leave that B. So if that's B, what would these be? 1/3. Yep. Does that make sense to everybody? So now my variable is B. That's how I want it. Now, I need the height. Here is the height. Right? What kind of triangle is this?
Right triangle.
Okay. So this squared plus that squared will be that squared?
It's 1, 9.
So what's this?
1, 6, or 1, 9.
What's that?
1/2.
Half of B.
Uh,
Isn't that half of B?
yep.
So 1/2 B squared plus H squared equals 1/3 B squared? Right? So what's 1/2 B squared?
1/4.
1/4 B.
1/4 B.
1/4 B squared.
I got a bad problem here, so I'm gonna have to make something else up. I'm sorry, this isn't gonna work. Does anybody see what's gonna happen? H squared is gonna end up being negative, and obviously that can't be. So I need to change something. The base of the isosceles triangle, let's say, is
Can you use Keller? Let's get it together.
1/4 the length of the legs. Let's try that. Sorry about that. Just trying to be helpful and do extra problems, make sure to plan ahead. Let's start over. So this is still the area. This is still the base. Now, if the base is 1/4 the length of the legs,
That's 4B.
then these are gonna be 4B. This is still gonna be 1/2 B, but now my Pythagorean theorem says 1/2 B squared plus H squared equals 4B squared. Right? So 1/4 B squared plus H squared equals 16 B squared. So B squared is going to equal, no, 8 has H, I'm sorry. H squared is going to equal 16 B squared minus 1/4 B squared. What is that? What's 16 minus a 4?
15 3/4.
I don't like mixed numbers. Don't like mixed numbers, so let's make it 63/4. That is 15 3/4. So what's H? Square root of 63 over 2.
B.
B. And then what do I do with that? Bring it over here and put it right there in my formula. fraction, multiplying together, what do you get?
63 over 4.
Root 63 over 4. And then how many b's do I have? B squared. There's your final answer.
Yeah.
Okay? That one has. Get that times here. So I got 1 times root 63 and 2 times 2. Alright.
Let's get to it.
Are we like preparing for pre-cal or is this like?
This is calculus.
Or I mean for calculus.
Yeah, that's why it's called pre-calculus, yeah.
Oh, shit.
Okay, all right.
And this is a potential test question.
Oh, totally.
Oh, God.
Yeah, the two we just did are easy.
Easy.
Well, compared to some of the ones we
Oh,
did
God.
yesterday.
Well,
Wanted to make sure.
are we? Will we be doing this after next quarter? At the end of this quarter? Will this be before the quarter ends?
Oh, will we have a test?
Yeah.
Quarter ends?
No, I'm not
I
trying to.
don't know, 'cause we.
Please don't.
Please don't. I'm going to keep my grade.
I want my solid
90%.
Please.
All right, we're back at our notes. Page 20, number 32, we have another mixing solutions problem. All right, so now we're mixing solutions. This is not what we just did here. That was review of what we did yesterday. At the very end of the period yesterday, we did a solutions problem. What was the general format I had you write down for that problem?
Amount times percent,
Yeah.
plus other amount times percent
Yeah.
equals amount percent.
Yep.
That makes sense.
So if we follow this guideline, we should be all set. So number 32, I have a 20% acid. I'm just filling in what I know. I have a 20% acid and a 35% acid. I am mixing them together, and what am I going to end up with? 25 liters of a 26%. Does this make sense to you? All right. Now, I need a variable, x. Is it okay if I just say, okay, I'm going to have x liters of 20%?
Yeah.
Do not say, okay, I got x of these and x of these.
Why?
You can call it y. Now, let me explain why you can't call it x. Why can't I call them both x?
Different solutions.
Because they could be different amounts, right? So this might be 10 and that might be 15. I don't know. But if you call them both x, then they're both going to be the same. And I don't know that they are. So we can call it y. There's nothing wrong with that. We can call it y. Problem is, you can't solve that equation because it has two variables in it. But wait, what do you know about x plus y?
X4.
It has to equal 25, right? You're dumping in x liters and y liters and you're ending up with 25, right? So what does that mean y is? 25 minus x. Now, if I put that in there, instead of y, if I put that in, is this equation solvable? Yep, because it only has one variable.
Instead of thinking about y, is thinking about it in the next terms.
Yes. Well, yeah, in order to solve it, we have to convert y into x's. Yep. Okay, so now we solve. So we have 0.20x plus, I use my calculator to help me. This is a distribute. So 25 times 0.35 is 8.75. And then 25 times 0.26 is 6.5.
When you did the y equals 25 minus x, could we have done like x equals 25 minus
You
1?
could have an excess here. And then the difference will be then, when you get your answer, it will be y equals, and that will be how much, 35% solution?
Yeah.
When I get my answer, it's gonna be x equals, and that's gonna be how much, 20% solution. And they're gonna be different numbers.
Okay.
Okay, but yeah, absolutely. Alright, now how do I solve this? Let's add these two together. So negative 0.15x plus 8.75 equals 6.5. Negative 2, oh wow, this is gonna work out perfectly. That's good. I think it's 15, isn't it?
Plug that back in.
Then, what was the question? How much 20% solution? That would be 15. And then how much 35% solution? That would have to be 10.
This whole page.
Make it better.
Ooh. Oh, God.
Oh, no. I like that.
I just did this one. You did.
There's no percentage. Ronan, what are you doing?
I said wrong. That's why.
Okay, now, I think because we're kind of doing that sort of thing, let's go all the way down and look at number 40 first. We'll work our way up because that's kind of harder ones at the top. So we'll start with number 40. So, as long as you have this framework, I think you can do these kinds of problems, if you think about it. These aren't too bad. So let's look at the last problem, number 40, investment return. Jackie invests $25,000, part at 5.5%, and the balance at 8.3%. How much is invested at each trade if Jackie receives a 1-year interest payment of 1,571? So, would you agree, on number 40, would you agree that her total interest is 1,571? Right? Where is that coming from? That's coming from two separate accounts, right? So it's coming from the interest on the 5.5% account plus the interest on the 8.3% account. And those two interests together add up to 1,571. Right? Okay. Does anybody remember from first year algebra, I think, was when you did this, I equals PRT?
Yeah.
I stands for interest, P stands for principal, which is the amount you invest. R stands for the interest rate, and T stands for time. Now, in our problem, time is 1 year. So I'm going to kind of ignore time because it's 1. So for this account, what is is the principal? How much did I invest? Do I know?
25.
Wait. What's the 25,000?
Best.
That's the total. She split it into two accounts.
8.345.
So I'm gonna call this X at 0.055. I invested X dollars at 0.055. And I invested Y dollars at 0.083. So here's my formula, guys. Make sure you can see what's going on. This is how much I invested. This is the interest rate. And in this problem, time is
1 year.
1.
1 year.
So I'm times by 1 if you want. You don't need to. Now I'm back to where I was in the last problem. I got too many variables. I invested a chunk of money here and a chunk of money here. What do I know about those two chunks of money? They equal, no, this is the interest. What did the investment, the amount of money I put in the bank? It equals 25,000. Okay, guys, I'm Jackie. I got $25,000 in my hand, I wish. I got $25,000 in my hand, right? I walk down to the bank and I hand you, Mr. Banker, invest this at 5.5%. Mr. Banker, invest this at 8.3%. So I took that 25,000 and split it into two pots. I called one pot X and one pot Y. What do I know about X plus Y? They have to equal the total that I had, right? 25,000. So, can I do the same thing I did a minute ago? This equation isn't solvable.
Y.
But I can say Y equals 25,000 minus X. And plug that in here. And then I have an equation I can solve. So 0.055X plus 0.083 times 25,000 minus X has to equal 1571. So does everybody follow what we just did? We knew X and Y had to add to 25,000. So Y is 25,000 minus X. So I put that in right here. I got that equation. So now I'll distribute. Quit yawning, oh my gosh. Do not yawn, this is fascinating stuff. Well, listen, if you're yawning today, you'll be crying on test day. So stop yawning. Sometimes the facts hurt. Negative 0.028x. That's what I got. I hope I subtracted that right.
Aiden wanted to try one. Aiden wanted
Well, before we take a test, we'll practice some more. But we really got to pay attention to what's happening now. I got 18,000 for X.
Where'd
Can
you
we
get
check that?
Yeah, where'd you get? Oh, you subtracted 2.
Just solving the equation. Like regular.
It's all coming together.
So, how much is invested in each rate? Well, 18,000 got invested at the 5.5. And then 7,000 got invested at the 0.08 or 8.3%. Now, little econ lesson for you. Some of you probably are already, you already have bank accounts, you're already investing. You all will at some point. If somebody's gonna pay me 8.3% versus 5.5%, why would I do this? Why wouldn't I put it all here? Because that's where I get my money, right? What else would I have to think about putting it all there? What happens almost always? If the rate of return is higher, the risk on your investment is, no, the risk is also higher, right? The risk is also higher. So if I am your age, I have a lot of years for my investment to grow. So I can be a little more risky if I'm your age. But when you're my age, when you're 65, do you want your retirement to be in a risky account? No way, Jose. No way. Okay. All right. Number 39. Unit conversion. A tire of a moving bicycle has a radius of 16 inches. The tire is making 2 rotations per minute. RPMs, revolutions per minute, rotations per minute. Oh, it's per second. Find the bicycle's speed in miles per hour. Okay. Now, this is like, I think in chemistry, we used to call it factor label, but I think you guys call it stoichiometry or something like that. Yeah, something like that. That's what we're going to do. So I am going to start with the unit that I know. I'm going to start with 2 revolutions per second. So does that make sense to you? 2 revolutions in 1 second. And I'm going to do a bunch of stuff, and I am going to end up with miles per hour. So do you understand? This is our beginning point. And that is our ending point, right? Now, I want you to think about this wheel with a 16-inch radius. If you put a blob of paint on the wheel and rolled it across the floor, you would have a blob and a blob and a blob, right? Wouldn't you see blobs spaced out? How far apart would those blobs be?
32 inches.
16 inches.
8.
62. 32.
8 inches.
Okay, stop. You guys are crazy. All right, so think of, here's the wheel, okay? Here's the wheel. If I put a blob of paint on that right there, every time that hits the pavement, it's going to leave a blob, right?
Oh, it's every rotation?
Every rotation, which in terms of the wheel is a circumference. Every time it goes around, every rotation, it's going to leave a blob, right?
Every second.
So how much,
2 times every second.
stop, how much distance will this wheel cover in 1 revolution? In 1 revolution, it is going to cover 32 pi inches. Because a revolution is a circumference. And what's the formula for circumference? 2 pi r. So if r is 16, a circumference will be 2 pi times 16, 32 pi inches. So every revolution is 32 pi inches. We've got to understand that. Because that's the only way I'm going to be able to get from revolutions to miles. I have to know what the distance of a revolution is. In this problem, it's 32 pi inches. Got it? So the very next thing in my thing here is going to be 32 pi inches is 1 revolution. Now, you know from your work in chemistry why I set the fraction up in that order. I need those to cancel.
Bottom, top.
Either way.
If you're gonna see.
Doesn't matter. This is going to end up canceling too. Alright, are you with me? I figured out 32 pi inches was 1 revolution. Okay? Now, that's great. I have inches and seconds. I need miles and hours. So, let's take care of the inches. I know that 1 foot is 12 inches. Now, why did I set it up like that? So these would cancel.
Oh.
And then I know that 5,280 feet are 1 mile. Yeah.
You don't give us conversions?
You have to go by inches.
You don't know how many feet are in a mile?
Technology.
Zero clue.
Mr. Gray gave us conversions in chemistry.
I'm sure it wasn't something common like that.
Come on, Mrs. Ford.
It's not very common.
Stop. Just take my word for it. There's 5,280 feet in a mile. Okay?
How do you know that?
I'm a runner.
Because I went to 4th grade. I don't know what okay. Now, again, I set it up in that order because I need my feet to cancel and I need to end up with miles on top. Right? So what do I have now? I have miles per second. Okay, that's not what I want. So what do I know about seconds? Well, I know there are 60 seconds in 1 minute. And now that will cancel with that. So what do I have now? I have miles per minute. Don't want that. So I know there are 60 minutes in 1 hour. These will cancel, and what units am I left with?
Miles per hour.
Miles per hour, which is exactly what I wanted. All the other units have canceled.
Where the pi have to cancel?
I don't want to cancel miles. I want to end up with miles.
Where'd the pie at?
Oh, it's still there. I haven't done anything with the numbers yet. You set your problem up so that you end up with the units you want. You want miles per hour. So I had to change, first of all, this is the big one right here. I had to change revolutions into a distance. Then I changed inches into feet and feet into miles. Then I changed seconds into minutes and minutes into hours. And I ended up with what I wanted. So now I can go to my calculator. Everything on the top, remember this is going to be my answer here. Everything on the top is going to be multiplied. So 2 times 32 pi times 60 times 60 is a big number, okay? But then I have to divide by everything on the bottom. So put a parenthesis because you're dividing by everything. So divided by 12 times 5280, that's it. So this thing is moving at 11.424 miles per hour. So type in, multiply everything in the numerator, hit equals, divided by parentheses, and then type everything in the denominator, and it equals. And it should give you 11.42.
Divide, and then we divide it by the top.
What's the name of the car tire?
No. Good year.
No, the diameter.
Oh.
Not a brand.
17.
17 inches, that's diameter or is it radius?
That's radius.
You're at 0.2.
My car.
Circumference is too high up. And I'm not giving you that. I am not giving you that. Such a baby. All right, here we go. This is a new problem because that was such a disaster.
37?
No, this is a new problem. So get another sheet of paper out and try again. Trying again.
Yeah, I was dumpster fire.
I like that.
What?
All right. So now we have a tire with a radius of 17 inches on a car traveling 55 miles an hour, and we want to know how many revolutions per minute is it spinning. Okay? So, what is the unit that we have to start?
Miles per hour.
We have 55 miles per hour, right? That's what we're starting with. And we are going to convert that into revolutions per minute. Right, that's the question? Okay. The key to this is always find the relationship between one revolution and that distance. So in other words, a revolution is a circumference. What is the circumference of this wheel?
34.
Pi. 34 pi.
Oh my God. I forgot the equation.
So the circumference, everybody agrees the circumference is 34 pi?
Yep.
So one revolution is 34 pi inches, right? Now, be careful. Where do I want the revolution to be? Top. So I'm going to say times one revolution, 32 pi inches. Now, nothing is canceling, but I know that in the end, I have to have revolutions in the top, right? So now I'm going to mess around with everything else. All right, I need to get rid of all these distances. There's no length in this problem. There's no miles or inches or feet or anything. So I'm going to remember that I'm going to tell you that 1 mile is 5,280 feet.
Yeah, I told you. I thought it was 34 over.
It's 34, isn't it?
Yeah,
Oh,
17.
34, yeah. Yep, you're right, 34. That was my circumference.
Will the revolution always be?
Yeah, that's it.
Yeah,
So,
I would be, without you.
Would it all, will revolutions always be like limited by how many minutes in a second, or we're trying to find minutes, right? So is that base, the second revolution per second?
No, this is just one revolution.
That's just one revolution.
Covers that much ground. Doesn't matter how fast it's going, every time it goes fast, it goes that much ground. Okay. Now, again, I'm trying to get rid of my units, so I got miles taken care of. Now, what do I know about feet?
3 inches, 12 inches.
There's 12 inches in 1 foot. Doesn't matter the order you do any of this, doesn't
I
matter.
didn't even know that.
But you need
No, I know.
12 inches in 1 foot. So those are gonna cancel, right? Well, wait a minute. Those are gonna cancel.
There we go.
Wait a second.
Wait a second.
They're gone, right? Which is good, because I don't want them over there. What do I need over there? I need minutes. So I know that 1 hour is 60 minutes.
There we go.
And now that, we'll get rid of that.
Oh, there we go.
And I am left with revolution
And minutes.
per minute. So now I'm gonna type in my numerator, 55 times 1, times 5,280, times 12. That's my numerator. Then I'm gonna divide by parentheses, 34 pi times 60. Whoa,
Whoa, scary number.
how many revolutions per minute is this thing making? 500, 543.748?
Not a lot of art.
I did that in
Right.
seconds.
Well, for this problem, it's a math like that.
Did you get that answer, or anybody else get that?
But if we wanted to change it to like an hour, we divide that by 60.
Well, we had an hour to start with. So we didn't do that. That would already be what I wanted to do. We didn't do this stuff. So remember, when you set the problem up, you focus on units first,
Yeah.
okay? All right. I'm gonna give you one more of those to work on by yourself for a second. So here we go. We're gonna do one more of them. Everybody ready?
One more.
One more of these.
Stoichiometry?
Is that what it's called in chemistry?
Yeah.
All right.
Oh, yeah. I remember doing that.
So, a tire has a radius, or let's say has a diameter of 28 inches. It is rolling at 215 revolutions per second. How fast is it going in miles per hour?
Wait, 200?
All right, so see if you can set this up. I'm not gonna say a word. I'm gonna give you about 3 minutes to see if you can get it set up. We'll see how well you get.
So we want miles per hour.
What's miles per hour? Our diameter is
56. Circumference is 28. 5.
Circumference is
About the same.
28 is
No, one at 56, right? 26
no, because the diameter is 28.
Got divided. How you times that?
You do not. It's
No.
Radius is the whole one, right?
No, that's
Radius is halfway.
Yeah.
Isn't circumference times by 0?
no, but that's the circumference you're finding.
Pi r squared. 2 pi r squared. 2 pi r squared.
Is it 56 pi?
No, it's 28 pi.
Sounds good. What do we start at?
We're gonna start with 28 pi.
So if you divide that by 2,
Over.
We start with 28 over 2.
28 over 1.
28 over 2.
That's how many revolutions?
No, over 1.
Wait, you
1
start
hour. Over 215 rev.
28 over
What's the
no.
circumference
That's one rev.
formula?
Is it 28 over
Okay, somebody tell her the circumference formula, because I'm not gonna say it.
Circumference is
pi r squared.
2
No.
pi r.
2 pi r. Oh, God.
I was 56.
No.
No. People, I am not giving you that again. You have learned that and learned it. Circumference is 2 pi r.
And the R
And the r is the radius.
I don't know. I'm really
Okay. I'm getting kind of crazy about all this, so I'm thinking that maybe the next time I see you, we'll have a little one problem quiz.
Oh.
No.
That's different.
No.
With the retreat.
Here we
With the
go.
retreat.
What unit do I have to start with?
28 pi inches.
215 revolutions per second, right? Now, Charlie wants to include this most critical step, and that is the step that links a revolution to a distance. So one revolution is a circumference. And for this tire, what is the circumference?
28 pi.
28 pi. So 28 pi inches is one revolution. Keeping in mind that I want to end up with miles per hour, that's my goal. Are there any revs in this fraction?
No.
No. So I want to get rid of that, and this will do it, right?
And then you go inches to foot, right?
Okay, we can.
Let's go.
The order, this is what I was telling Charlie, the order you do your steps doesn't matter. The idea is you gotta make everything cancel out. So if you wanna go, if you wanna say 1 foot is 12 inches.
There we go, now cross.
That will take care of that.
And then
And then, 1 mile,
5,200 something.
5,280 feet.
There we go.
There we go.
And then,
And wait, now we are miles per second.
oh, and then there's 60
60,
seconds.
1 over
So
60.
60 seconds is 1 minute.
And then 60 minutes of 1 hour.
60 minutes
I'm gonna get the hang of this one.
is 1 hour.
Jake, we got the first step wrong.
And what are we left with?
Miles per
What
hour.
unit is on top? Miles? What unit is on the bottom?
Hours.
Hours. That's what we want. So now we go to our calculator. And we have learned we're using the pi button, we're not using 3.14. So 215 times 28 pi times 60 times 60.
Wait, how, like, do you put that in parentheses?
You don't need to, you just hit equals. Now, if you're not building a fraction on your calculator, then you gotta do divided by parentheses 12 times 5280. That's it. Look, how fast is this thing going?
Wait.
So 1,074.567 miles per hour.
I think I'm my brain's
Alright, so
Oh, I do get it.
how do we start? Start with
Grabs over seconds.
what they gave you. Revolutions over seconds. Ultimately, you knew this was your goal. I would always suggest, you don't have to, but the key is changing the revolution into a distance. So build that fraction in some way. That one revolution is a circumference. Right? And then work on changing the inches into miles and the seconds into hours. Okay? Now I'm assigning 1.7, we still have a couple more to go, but I'm assigning it to you Tuesday. On Tuesday, I'll have some review materials for you.